This demo will show how the SAC, or Storage Access Controller, functions and how we can use it to make networking more secure. What we will show you is a rudimentary SAC prototype using manual controls to demonstrate the proof of concept and its ability to establish a network-like environment with 2 host PCs, and how the SAC can manipulate this environment in a way that the host PCs cannot override and take advantage of other resources on the network. Our prototype shown here has 2 attachment points for the host PCs and 4 ports for USB devices. In stage 1, we demonstrate that this USB-based SAC is USB compliant. The SAC is first attached to host PC number 1 and then host PC number 2. We then attach a USB storage device to host number 1 via the SAC, so only host 1 recognizes the attachment of the device and assigns the device as its drive E. A second storage device is then attached to host number 2 via the SAC, which only host 2 recognizes and assigns it as drive D. As part of USB compliance, the hosts each recognize when we detach their storage devices. In the end, we disconnect the SAC to end stage 1. USB compliance means that the SAC doesn't affect how the host recognizes the physical attachment and removal of devices or changes the device's function. Stage 2, Network Security Fundamental number 1, Access Control to SAC Network Storage. We reattach the host to the SAC. We now configure the SAC to disable access between the hosts and the devices. We then reattach the SAC network storage devices. Notice that despite being plugged in, the SAC network storage devices are not accessible to either host 1 or host 2. We now reestablish the access rights to allow host 1 and host 2 to access their respective SAC network storage. And as you can see, host 1 can now detect the SAC network storage and access the previous host1.hello.txt file. Likewise, host 2 can detect its SAC network storage and access the previous host2.howdy.txt file. This ends stage 2. Stage 3, Network Security Fundamental number 2, Controlling the host's data environment, i.e. controlling what network data the host sees regardless of what data is physically present on the network. In Security Fundamental number 1, we showed that we can completely hide any network data source from any host. Here, we reconfigure the data network so host 1 sees twice the number of SAC network storage than what it can physically access. Here, storage F drive is an exact clone of storage E drive. Such a feature is useful for failover, remapping, and redundancy. Likewise, we can control what host 2 sees as well. E drive is an exact clone of D drive. The SAC network is itself a security sandbox, if you will, a real sandbox without the need of virtual machines. Stage 4, Network Security Fundamental number 3, Server-Free Sharing. The SAC network is the world's first server-free network. Clients can share network resources without the need for any client-server interactions. Server-free sharing eliminates the problem of access privilege escalation. Note, that this example shows rudimentary file sharing supported by the SAC network. To share files, host number 2 will be allowed to discover and access the SAC network data that is available to host number 1. At the same time, host number 1, as we've configured it, cannot discover and therefore cannot access other SAC network data reserved for only host number 2. It's important to note that these are native functions of the SAC network, meaning that there are no custom drivers or software involved. Here, when permissions are set, the same network data, represented by the host1.hello.txt file that is accessible to host number 1, is now also accessible to host number 2, as shown here. Stage 5. A network application example. A rudimentary email server. Here we show the flexibility and potential of our SAC network. On the recording host, the originating email server, a simple text file is created and stored locally. Using the file transfer function of TeamViewer on the recording host to mimic an internet server-to-server email transfer, this save file is transferred to host number 2, the local email server on our SAC network. The file was transferred to D drive on host number 2, which we have assigned to be the private mailbox storage for host number 1 on the mail server. On a larger network, all other client hosts would also have their own private storage on this local mail server and being private. Only the particular client would be able to discover its private mailbox and access mail within it. Here, we are configuring the network to allow host number 1 to access its private mailbox that is shared with host number 2. Host number 1 now checks its mailbox. And voila, host number 1 now retrieved its private mail without being served by the local mail server. Thanks for watching. Working on more scenarios, so stay tuned for more.